Sorry, I didn't see you. Are you here to learn about cellular respiration? Okay, give me just a second. I'm really tired. Let me try eating some of this sugar.
Man, do I feel energized! But how does sugar give me all this energy? Let me show you.
To begin with, table sugar is broken down into the simple sugar glucose. Glucose has a lot of energy stored in its chemical bonds. However, when I eat glucose, my muscle cells do not directly use electrons to make my arm twitch like this. Instead, through cellular respiration, the electrons in glucose are used to make adenosine triphosphate, or ATP. ATP is what my muscle cells use to function. For example, take my cell phone. This boiling pot of water has a lot of energy in it, but if I were to just throw my cell phone in, it wouldn't charge my cell phone. My cell phone needs electricity to work. You see, just like our bodies and our muscle cells need ATP, Sorry about that little mishap. My phone will probably be alright. Anyway, to get back on topic, cellular respiration is the process in which the energy in food is converted into ATP. There are three parts of the process. The first step is glycolysis. The second step is the citric acid cycle, and the third is the electron transport chain. The word glycolysis has two parts. The first part, glyco, relates to the glucose, while the second part, lysis, means to break down. After using two molecules of ATP, glycolysis gradually breaks down glucose into two molecules of pyruvate. Through a process called substrate level phosphorylation, glycolysis actually produces 4 ATP, leading to a net production of 2 adenosine triphosphate molecules. Additionally, while glycolysis is breaking down the glucose, it gradually shaves off electrons into a molecule called NADH. NADH is a transport molecule that then transports the electrons to a later part of cellular respiration. The 2 pyruvate molecules then undergo a quick intermediate process, turning into acetyl coenzyme A, while also producing an NADH molecule as well as a CO2 molecule. The acetyl coenzyme A then enters the citric acid cycle. The citric acid cycle is a circular series of chemical reactions. You put in acetyl coenzyme A, and instead of clean clothes, out comes 1 ATP molecule, 3 NADH molecules, and 2 CO2 molecules. We have now reached the final stage of cellular respiration, the electron transport chain. Embedded in the inner wall of the mitochondria is a series of proteins that make up the chain. All electron-carrying molecules from glycolysis and the citric acid cycle deposit their electrons at the top of the chain. At the bottom of the chain is an oxygen molecule that removes the electrons and turns into water. A constant supply of oxygen is required to keep the electrons moving throughout the chain. As the electrons cascade downward, they push hydrogen ions into the intermembrane space, making the hydrogen ions accumulate in the small volume. As an example, picture a tiny closet with a revolving door. If you put 12 people in the closet, they are not going to be happy and will push through the revolving door to leave. Well, the hydrogen ions push through a revolving protein called ATP synthase, which produces ATP as it spins around. This proton motive force drives ATP production, and it creates approximately 28 ATP molecules per glucose molecule. I hope you understand the basics of cellular respiration. As for me, I'm feeling pretty tired. My sugar's running low. Catch you later.